Now let's focus on the softmax value. At this stage, we have already calculated Q multiplied by K transpose divided by the square root of the key dimension. The next step is to apply the softmax function to this result. Softmax is applied across all the rows of the matrix. For example, after performing softmax on a 3x3 matrix, suppose the original value minus 0.06 becomes 0.36, another value becomes 0.24, and another becomes 0.40. The sum of these values in each row will equal 1. What does this represent? Let's say our tokens are and poem. The value 0.36 indicates that the token A is 36% related to itself. The value 0.24 shows that it is 24% related to the token poem. Similarly, the value 0.40 indicates that poem is 40% related to itself. In other words, softmax represents the degree of similarity or relevance among tokens. You can think of this as a summary of relationships within the sequence. For example, the token right might be 36% similar to itself, 40% similar to, and 24% similar to poem. The sum of these relationships always equals 1. This is how softmax captures contextual similarity among tokens. In the next lecture, we will discuss the value matrix V and how it is multiplied to produce the final attention output.